As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-thru or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk. I'm Neil Degrasse Tyson, your personal astrophysicist, and this is a Cosmic Queries edition on the search for life in the universe. Co-host Jordan Klepper. Jordan, I miss you, man. I had you as a co-host once, and we got to do this more.
Neil, I'm glad to be here. Today we're searching for life, and we're searching for connection, and we've connected. So step one, completed. I need it more than ever right now. So it's good to hear your voice. I need some consolation. Let's hope there's more things out there in the universe. Fingers crossed.
Let's hope so. Let's hope so. So while I carry some expertise in this, I carry nowhere near what is necessary to be the expert on this Cosmic Queries. And we've got Kevin Hand. Kevin from the Jet Propulsion Laboratories, Pasadena, California. Welcome to Star Talk.
Thanks, Neil. Good to see you again, and thanks for having me.
Yeah. And you just published a book called Alien Oceans. That's audacious.
Thanks. Yeah, it's an exciting topic. At least I'm passionate about it, and I'm excited to share it with everybody out there.
It's got a big fat subtitle: "The Search for Life in the Depths of Space."
That's
Love
right.
it, by Princeton Press. So we know it's going to be sort of academically enlightening. And plus, I just noticed that your Twitter handle is Alien Oceans.
That's right. It's this book.
What's up with that?
It's funny the way you can coordinate these things. So yeah, I've been working on the book for a long time, and in the book we dive into our own alien ocean here on Earth, and then we go into our own backyard in the solar system and look at oceans that exist in the outer solar system that could harbor life.
Doctor, do you know if Alien Oceans will be open on Memorial Day? Is that a local government decision, or do you have any insight?
You can open the book.
I'll take what I can get.
So, Alien Oceans, why not look for aliens in places other than oceans?
Well, we are, and we should, and I hope that we can pursue all of these different dimensions and places when it comes to exploration. But these moons of the outer solar system, these worlds like Europa, Enceladus, and Titan, these are worlds where liquid water could be today. And of course, if we've learned anything from our study of life on Earth, it's that where you find the liquid water, you generally find life. And so these worlds are incredibly compelling places to go and potentially not just find life, but life that is alive today, life that we could study and understand its fundamental biochemistry.
So you are using an Earth-biased approach to the search for life elsewhere.
That
confess it here and now.
Get him, Neil. Get him, Neil.
As Carl Sagan used to say, he's a carbon chauvinist, and this is a really important point.
Jordan, he's speechless. See, so he knows he's guilty.
I know. This is what it is. This is when you poke through the bias, you get at what's really underneath, and it's nothing. All right, it's like the atmosphere of Jupiter. It's nothing. I don't fact check
Jordan,
that.
What do you think of carbon chauvinism?
I come from a long line of carbon chauvinists, so I have empathy towards it. My grandpa was a carbon chauvinist. My dad, when he has a few too many drinks, is a carbon chauvinist.
Thanksgiving's just a mess.
It's really a mess. Don't bring hydrogen in there at Thanksgiving. Yikes! Explosive.
But wait, it's one thing to be made of carbon. Carbon is a pretty fertile molecule. I mean, an atom to make all kinds of molecules. But you're going beyond just whether life is made of carbon. You're also asserting that it requires liquid water. That seems to me yet another. Right. So it's not only a carbon chauvinist, you are a liquid water chauvinist.
That's right. And so now in the book, I do go into, there's a whole chapter on speculating about a periodic table for life. Could there be many different modalities, many different chemistries, et cetera? But there's a good reason to, at least initially, target our search for water and carbon-based life. And the reason for that is because, of course, scientifically, we need to frame an hypothesis. And so based on life on Earth and how life on Earth works, we can put forth the hypothesis that if you bring together liquid water, carbon, and a smattering of roughly 53 other elements from the periodic table, plus some energy, et cetera, to maybe get...
Wait. 53, that's not a smattering. That's half the elements.
That's a good... That's a heck of a picnic of elements right there.
Some of them are more important than others.
Okay.
So it's a little bit of a spice mix.
Some elements are... First you're a carbon chauvinist, and now you're completely disregarding half the elements? Who is this guy, Neil?
I don't know.
It's really carbon and nitrogen, and you got some phosphorus, maybe a little sulfur if you like.
Oxygen, okay.
Yeah, those the big 5-6 elements in there. But the key back to the water and the carbon is that we can formulate this hypothesis that if conditions are similar to what we find in habitable environments here on Earth, and potentially in environments that we think were conducive to the origin of life, if those kinds of environments exist elsewhere in our solar system, then perhaps those environments, those alien oceans, could have given rise to life. There could be a separate, independent origin of life, and those worlds could potentially be inhabited.
I got a philosophical question for you. If you are only looking for life that you expect, and you find it, won't you be missing all the life that you don't expect? Wouldn't that life be way more interesting than life that you expect to find?
Right. And so here's the key. With any mission, with any spacecraft mission, or frankly, with any experiment that we do in a lab or here on Earth someplace, we have to design the experiment around an hypothesis, but also try to make sure that the experiment is well formulated such that we can make discoveries that we did not expect to make.
A serendipity mode.
A discovery mode, a serendipity mode, I think. Yeah, that's a nice way to put it.
Set yourself up to be surprised so that your lack of creativity in the planning stages is actually a bonus in the discovery stages.
That's right. It's a good way to spin it. Exactly.
So, Jordan, you collected questions from the internet on this very subject. So what do you have? If you lead off with our Patreon, because we're beholden to them as supporters of the show, but then we'll spill out into others who have chosen to not support the show. But we don't lead with them, that's all.
I'm going to start right off with Patreon patron Svenbjorn Bird. Svenborn's question is, will we have probes in the near future that will be able to take photos or videos beneath these water worlds?
Ooh, nice.
Well, it's a great question and one that is very near and dear to my heart.
Because you have to dig through the ice. The water is not surface water, right? It's like below like a kilometer thick layer of ice. So you got
That's
you
right.
got your work cut out for you.
That's right. And so I believe it was Sven. It really depends on how you define near term. So,
In the next 1,000 years, sure.
right. So this business is not for the faint of heart. I've been studying Europa and working towards trying to get missions out to Europa for 15 to 20 years now. And we are a bit closer. So NASA has committed to a flyby mission, a mission that will orbit Jupiter and fly by Europa some 45 plus times. And that's called the Europa Klepper mission. And I'm part of that mission, but I'm also working very hard to get a lander down to Europa's surface. And hopefully that mission would happen hopefully it would land in the 2030s timeframe. But that's highly uncertain. We have no commitment from NASA or the government, et cetera, to get that mission done. So
I just have to bring Jordan in on something. Jordan, you should know that in science, one of the first rules is whatever experiment you're a part of, it has to finish before you die. Okay, that's just a.
I will say what you're describing. I have a bunch of screenplays that I don't think will get finished in my lifetime. I have an entire idea about me as a sexy cowboy that for some reason I've had studio execs tell me this is not going to happen in your lifetime.
No, it's this lifetime, right?
It's not in this lifetime. So, but I get that you want to look this. I'm leaving this for the next generation.
Yeah. So Jordan, sexy cowboy script and Europa melt probe.
Wait, so that 2030 mission does not yet go through the ice. That just lands and looks around, right?
Well, and it scoops in. We've got all sorts of novel drills and ways to sample the upper tens of centimeters. And that would help set the stage for a follow-on mission that would drill or melt through the ice and potentially get into the ocean.
After you're dead.
well, here's the thing, Neil. It's,
so the answer to Bien Zvoren is no. That's your answer.
Depending on how you define near term. No, keep in mind, it was 400 years ago, over 400 years ago, that Galileo discovered these moons. And so as depressing as it can be to work on these missions that take so long, I do like to keep it in perspective in that for the first time in the history of humanity, we can actually get this exploration done. It's been 400 years since Galileo discovered these moons. I guess I sort of approach it like, these spacecraft are our modern version of cathedrals. These are incredibly complex undertakings. They take generations. They take a long-term commitment, which obviously in some of this day and age and the political whims, long-term commitments are hard to come by. So it's frustrating, but at the same time, I feel fortunate that I get to be a part of even a little bit of this.
Jordan,
Doctor.
He did it again, Jordan. He can't get it built on time, so now they're cathedrals.
Cathedrals. Doctor, as an atheist myself, now you're making me not want to get into a spaceship. That was like my last dream. I already know I'm not going to get into heaven. Now I can't get on a spaceship? What are you doing?
Well, here's the thing. Technologically, coming back to the main question, there is nothing. There are no magic wands that need to be invented to get us through the ice.
That's an important point, a very important point.
And as you argue a lot, Neil, getting to the nearest star, if we were tasked with doing that within 100 years, we'd have to invent some newfangled warp drive, and it's a magic wand. There is no magic wand needed to be invented in order to get through the ice of Europa and into the ocean.
Mm-hmm.
If you could magically transport the Alvin submersible, one of our primary human submersibles that we use for the exploration of our ocean. If you could magically transport that to Europa's ocean, it would do fine for at least the upper half of that ocean. Once it got to the lower half, the deeper half, the pressures would be a bit extreme. But nevertheless, most of our submersibles would work fine.
Wait. How deep are Europa's oceans?
So Europa's ocean is about 100 kilometers or 60 miles in depth.
Oh my gosh! And on Earth, the deepest is like 5 miles down, or
7 miles, 11 kilometers.
7.
And
Wow!
just by a fun quirk of the solar system, Europa's gravity is about 1/7 of the Earth's. And what that means is that even though the ocean is about 10 times as deep as the Earth's, the pressure at the depth of Europa's ocean, at the seafloor of Europa's ocean, is comparable to the pressure in the depth of the Mariana Trench, the deepest region of our own ocean.
Mm-hmm. Okay, cool.
And so the submersibles that go down to the Mariana Trench would do well in Europa's ocean if you could get them through the ice.
You just have to fly it there and melt the ocean and melt the ice and then sink it.
Yeah.
And doesn't Alvin have somebody in it?
That's right.
And you have to send an astronaut to go.
Well,
That's all.
so of course,
This is a complicated cathedral.
beautiful tapestries, though, Jordan.
I think it's what you're saying. It's like it's gonna need a miracle. is what you're saying.
Hence the cathedral reference.
to get the funding.
Now I understand.
All right, Jordan, give me another one. Another Patreon question. I think.
All right.
That one?
Yep, this is from a Patreon patron, Dave W. Given the high chance that life exists in the oceans of Enceladus, why isn't Saturn included in the habitable zone of our solar system? Is the idea of a habitable zone even helpful for the search for extraterrestrial life?
Love that question. Kevin, go for it.
Yeah, it's a great one. And two pieces I want to dive into there. First, on the habitable zone, the question is spot on. And I go into this in the book. These alien oceans of the outer solar system are redefining the habitable zone. In the early days of astronomy and planetary science, there was this conception of the habitable zone where in order for a world to be habitable, you had to be at just the right distance from your parent star, in our case, the sun, such that liquid water could be maintained and sustained on the surface. If you were too close, like Venus, you were too hot. If you were too far away, like Mars, you were too cold. If you were at the Earth-Sun distance, you were in that kind of Goldilocks zone or the traditional habitable zone. But what these worlds like Europa and Enceladus are teaching us...
You know what they're teaching us? That we have to take a break. And when we come back, we will find out what the modern understanding of a habitable zone. But Jordan, help me.
It's hard. Habitable, right?
He's got us all confused.
Encephalitis, Mars. The Mars zone, just let's say...
Goldilocks zone. There you go.
There we go.
The emerging Goldilocks zone has a different understanding. So, Kevin, we'll get right back to you right after this break. This is Star Talk.
Live with luxury. Live with power in the all-new Toyota Sienna Platinum. The all-new Toyota Sienna is an all-hybrid powertrain with upgraded style and available features like all-wheel drive, a second-row captain's chairs with ottoman, and a 1,500-watt capable power outlet. Live the Sienna life. Or live with style and live bolder in the all-new Toyota Sienna XSE. With upgraded interior and exterior styling and available features like 20-inch dark wheels, an HD entertainment center, and hands-free door and liftgate. Whichever you choose, live the Sienna life. Toyota. Let's go places. Live with luxury. Live with power in the all-new Toyota Sienna Platinum. The all-new Toyota Sienna is an all-hybrid powertrain with upgraded style and available features like all-wheel drive, a second-row captain's chairs with ottoman, and a 1,500-watt capable power outlet. Live the Sienna life. Or live with style and live bolder in the all-new Toyota Sienna XSE. With upgraded interior and exterior styling and available features like 20-inch dark wheels, an HD entertainment center, and hands-free door and liftgate. Whichever you choose, live the Sienna life. Toyota. Let's go places.
We're back. Star Talk, Cosmic Queries, the Search for Alien Life edition. And we have my co-host, Jordan Klepper. Jordan, love having you, man. Love it.
It's fun to be here. I'll take all the connection I can get. Thank you, Neil.
All right. And by the way, you tweet at Jordan Klepper, right? That's your pure Twitter handle.
Yep. You can find me easy. Just know my name, which is maybe tough. But if you've done the hard part, figured out who I am, you can find me on there.
And Kevin Hand at the Jet Propulsion Labs. You were director of the Deep Ocean Project. Did I say that right?
The Ocean Worlds Lab.
Ocean
at JPL.
Worlds Lab. And at the Jet Propulsion Labs in Pasadena, California. And we left off. We left the last segment where we understood the traditional classic definition of a habitable zone, a Goldilocks zone, not too close, not too far, just right for liquid water. What do we do about that idea now?
Right.
Now that we got moons way outside that zone that are kept warm. What's going on?
Right. So we've got this new Goldilocks in town where the energy for maintaining and sustaining liquid water comes not from your parent star, but rather from the tidal tug and pull that these moons experience as they orbit their giant primaries. Europa orbits Jupiter, and Jupiter is some 318 times as massive as the Earth. And Europa is about the size of our moon. And so as Europa is orbiting Jupiter, it's getting tugged and stretched. And that internal mechanical energy is converted into heat, and that heat helps maintain the liquid water ocean beneath Europa's icy shell. So it would
otherwise be completely frozen. Without
that's right. There would be some radiogenic decay, some heavier elements that might supply some heat that could maintain an ocean.
Radiogenic decay, radioactivity.
That's right. Exactly.
Okay.
And so the tides combined with the radioactivity provides some heat to maintain an ocean beneath the ice. But there's so in this new habitable zone, I don't want it to go unappreciated that another curious, beautiful fact of our universe is that ice floats. And if ice did not float, then even if you had the tidal energy for maintaining the liquid water in this kind of new habitable zone of tides as opposed to solar energy, if ice did not float, you would not have a nice thermal barrier over these oceans, protecting these oceans from space. And so just like, building an igloo or building a snow fort where you crawl inside and all of a sudden you're nice and warm, ice and snows on Europa and Enceladus form a thermal blanket over the oceans that are being heated from within by the tides.
Is it fair to say that if you crawl into an igloo, you're nice and warm, as opposed to saying if you crawl into an igloo, you're not as cold as you just were?
Well put. Yes, fair enough.
I'm just saying. I don't
Yep. Right.
But when I think igloo, inside or out, I'm not thinking cozy. I'm just saying.
I see a positive here. You're telling me a martini that's shaken with a nice little ice layer is going to taste similar on Europa as it would here in, say, downtown Manhattan.
I'll go with yes.
I don't know if he actually said that, Jordan, but
I think play that back. It feels like it was mostly
rewind
cocktail understanding. Yeah, it was something about ice floating, the right amount of gin, a little bit of sweet vermouth, a kiss of olive, something. Right? Is that what I was listening to? Or is that what I'm thinking
there's
about?
lots of salt on Europa. You can make a margarita if you want. It's there's.
So what we're saying is we can still think of a habitable zone, but not as some a restricted place or in the circumference of a star. That a habitable zone is any place you can have liquid water, and that could be wherever there's a source of heat.
That's right. And so these subsurface oceans, as I describe in the book, these Europas could be ubiquitous. And so when we think about habitable real estate in our universe, these subsurface liquid water oceans could be the predominant place where life resides.
And especially since there's so many of those such places in our own backyard.
That's right.
I see.
Yeah. Now the questioner had the beginning part of that question was, since it's likely that life exists within Enceladus, I just want to pick that apart a little bit. We don't know whether or not life is likely. We can put forth that hypothesis that the conditions within Enceladus and Europa and some of these other worlds might be conducive to life's origins and habitability.
But Kevin, that's the scientist's way that gets written as a headline by the press saying scientists found life on Enceladus. You just said the conditions are such that it was possible that we could have the likelihood of life. And then life found on Enceladus.
But we got to sell some papers. We're taking it. We're going to print. We're not even fact checking. All right, this guy said something about cathedral. I don't know. Stick that at the end.
Martinis, it's all there. It's all in the same article.
But the as much as I would love to find life beyond Earth, as beautiful as that discovery would be, the non-discovery of life, if we were to go to many of these worlds, Europa, Enceladus, Mars, and find not a whiff of life, that also is a potentially equally profound discovery in terms of the rarity of life and the kind of biological singularity that life on Earth might represent. So
Jordan, he did it again. He said, if our experiment fails, that's a great result.
That's great. It really is.
That's the third time he's...
I wish I had listened to your explanation on this podcast back when I was taking classes in high school, that I could use these explanations to my mother. Of like, I could do well, I could study, I could pass the test, but if I fail, there's still some life lessons that I'm learning from
Yeah,
this.
but that's it. When you're doing an experiment, as long as it's a well-designed experiment, the outcomes yield knowledge either way.
Tell that to the grand school, okay? I'm not buying
That's
it.
very good. So Jordan, give me another question. What do you got going there?
I do. You know what? This is coming from Facebook, and he's coming at us. He's questioning some assumptions here.
Okay.
This is Lee Daly from Facebook. He wonders, is the life in our own oceans not terrifying enough?
Whoa.
Shots fired, Lee.
Yeah, I don't know quite how to interpret that. I would say I've gotten to make 9 dives to the bottom of our ocean, and also I've been a part of a number of expeditions to send robots down to our ocean. And it's not, I wouldn't qualify it as terrifying. It's beautiful. It's astonishing. It's just jaw-droppingly bizarre. On one of my dives, we encountered this 2-meter diameter space bagel-like creature that was this undulating jellyfish. And seeing life within our ocean and studying life within our ocean helps inform not only how our home planet works and the understanding the biological diversity of planet Earth, but it also just guides us and inspires us when we think about these deep, dark, distant oceans beyond Earth. And in particular, life at the hydrothermal vents in our own ocean is really the kind of oasis in the deep ocean that we look to when we think about what might exist in the regions where photosynthesis cannot operate in these ice-covered oceans like Europa and Enceladus.
Wait, so hydrothermal vents, that's where the continents are separating and you got heat. There's a source of heat that's not the sun.
That's right.
That's under the and deep, so deep that the sun can't reach. Sunlight doesn't reach it. So if you're going to have life there, it's got to figure something out.
That's right.
That's not in your biology book.
Yeah. That's right.
Yeah.
So traditionally, we learn that the food chain, animals eat animals and plants and so on and so forth. And eventually you get down to photosynthesis. And photosynthesis serves as the base of the food chain. Well, when you go into the depths of our ocean, of course, sunlight doesn't get there. And so photosynthesis can't form the base of the food chain. But what microbiologists found back in the late 1970s is that these hot springs, these hydrothermal vents at the bottom of our ocean, provide a tremendous menu of interesting compounds that microbes love to eat for lunch and dinner, and they then do chemosynthesis using the chemistry to synthesize the compounds they need. And then other organisms eat those microbes and so on and so forth. So you get this food chain that is fed off the chemistry of the vents. And we think that kind of dynamic, that kind of ecosystem might be an interesting example for what could happen within these ice-covered oceans of the outer solar system.
All right, that keeps you going.
Yeah.
Very good. All right, so what do you have next, Jordan?
I got one. I got Lori Muller from Twitter. Lori wonders, do we have the ability to identify non-carbon-based alien life? Or will our perspective prevent that? What's NASA's official criteria for identifying alien quote-unquote life?
Yeah, this is a great question.
In fact, Kevin, let me shape that a little differently to include our part of our earlier discussion. If you are looking for carbon-based life, does that preclude you from finding silicon-based life?
The short answer is no, as long as you bring the right tools with you. And I'll give you a couple of different examples. And again, there's a whole chapter on this in in Alien Oceans.
But for those who just joined us, Alien Oceans is a book.
Thank you.
Context clues chapter would really help you figure that out. But thank you, Neil. Not going to let something slide
I just want to be in full disclosure.
Yes, there we go.
Okay.
We're not just so cavalierly talking about alien oceans. Just throwing it out like.
Yeah, go take a swim with the sharks and learn my book.
Right. So this is a great question, Lori, and it's one that has enlisted many PhDs, many grad students, many scientists, and it's one that we debate in the community constantly. And there's a thing called the ladder of life that you can Google and you'll find on NASA's official astrobiology webpage, this sort of tier of what we call biosignatures and kind of the efficacy and fidelity of various biosignatures leading up to claiming that you have actually detected life. And so, for example, if we sent a submersible down into Europa's ocean and a Europan octopus came up and waved at the camera, well, that would be one heck of a biosignature. We would have motility. We'd see this moving creature. We would potentially...
And you wouldn't care what the hell it was made of.
We would run with that's front page news right there. We would run with that. We actually have pictures. Yeah. Great.
And to be clear, when we are talking about the search for life in our solar system, whether it's Mars, Europa, Enceladus, Titan, we are largely talking about the search for even the tiniest of microbe. Such a discovery would revolutionize our understanding of biology, and we would, for the first time in human history, know that biology actually works beyond Earth. But so...
Wait, just to be clear, Kevin, if the life you find on another planet is made of DNA, then it doesn't revolutionize anything.
Yes, it could. Let's come back to that though, because that folds into the.
I don't mean to pick a fight or anything.
No, it's a great one.
Neil, we need for the ratings. This is go with your instincts. This is good. We need this. All right, we got to stand out.
Nerd fight.
There we go. So to Lori's question, there is this ladder of life, and we've developed a biosignature framework. In other words, that not just one measurement is enough. You have to make multiple complementary and redundant measurements in order to have enough biosignatures that you can then claim that you've detected life. And you want to make sure that you have biosignatures that are as universal as possible.
Wait, Kevin, just to be clear, we have to alert our audience. This is an astrophysicist using the word universal to apply to the universe. Most people on Earth who use the word universal mean all over Earth.
That's right. Yes, we are talking about universal biosignatures being biosignatures that could apply throughout the universe.
Right. When it says, this is a universal law or Miss Universe, no, this Miss Earth, really, you're talking about there.
That's right.
Yeah. And to be honest, when I use universal truth, I'm just talking about what I believe.
That's all we can ask for, Jordan. I mean, it's...
sorry to interrupt, Kevin.
But think about
universal
universal biosignature. So think about if we were to use a DNA PCR machine or instrument in searching for life on Europa. PCR, polymerase chain reaction, that's obviously what we're using for looking for a lot of the COVID-19 virus. It's what is used by a lot of companies doing genetic analyses. And it's great. But that kind of instrumentation is contingent on that life using DNA. And so if we sent that kind of instrument to Europa or Enceladus or any of these other worlds, we could miss non-DNA based life. Meanwhile, so we're not going to send an instrument.
Life could be like rodeo riding the probe,
right?
And your device doesn't find DNA, and so
and so we say, game over. But an instrument like a mass spectrometer, I like to make the analogy to a mass spectrometer kind of being like a carpenter's hammer. You'll never go to a job site and find a carpenter without a hammer in their tool belt someplace. And mass spectrometers are a great way of sorting and identifying the various compounds, be they carbon compounds, be they silicon compounds, be they nitrogen compounds, you name it, a mass spectrometer gives you that inventory of compounds. And what's nice about that is that life, whether it's carbon-based life, silicon-based life, all sorts of other permutations that we can't even imagine, life almost certainly needs to be specific in the compounds it uses. In other words, life will use a discrete set of subunit molecules to build the larger molecules of life. For life on Earth, it's amino acids building proteins, nucleobases building DNA. So a mass spectrometer would allow us to identify that kind of specificity in the building blocks.
Are they included in these missions?
Yeah, so mass spectrometers.
Okay.
Yeah, on the Europa lander model payload, that's like prime instrument number one is bring something that can, without bias, give you the molecular inventory of what's there. Now, to DNA, to your question about DNA, which is, I love this one because it really is quite profound. If we go to Mars, and I love Mars, I'm doing some work on Mars 2020. It's a beautiful world.
Yeah, me too. Just so, we're all on the same page. Yeah, we don't need to brag about it. Equal footing. Continue.
Right. If we were to go to Mars and find evidence of DNA-based life, and this would have to be in the subsurface of Mars because our current search for life on Mars is in ancient rocks. And DNA doesn't last long in ancient rocks. But let's imagine that we got into the subsurface of Mars and found some water, and then we found DNA-based life. I would, and many of my colleagues would probably conclude that that is evidence of transfer of DNA life from Earth to Mars or Mars to Earth at some point billions of years ago, just because Mars and the Earth are near neighbors, and impact events, comets, asteroids, etc., hitting the Earth could have easily ejected material that then went to Mars or vice versa. But with Europa, if we went out to Europa or Enceladus and we found DNA-based life, it's much harder for Earth to send microbially laden rocks out to Jupiter. And then once out there, it's much harder for those rocks to actually hit Europa instead of Jupiter. And even if they hit Europa, they're going to be coming in at something like 11 kilometers per second or faster. And then they annihilate themselves upon impact on the ice. And it's just a lot harder for an Earth rock to bring life to Europa or Enceladus than it is to Mars. So if we found DNA-based life on Europa, I would argue that that is evidence of biochemical convergence towards DNA as a fundamental molecule for life.
Analogous to if you go to a rocky moon somewhere else and you find quartz, or
bingo.
The geologic analog would be the same minerals are there that you find in the geology here on Earth.
Exactly. And just like on Earth, we've had eyes. Eyes have evolved independently some 50 times. Maybe DNA is just kind of the convergent biochemical molecule that happens. Or not.
And we're just too stupid to figure out how easy it is for nature to accomplish
exactly. but this is why the outer solar system is so compelling, because there's liquid water there. And so these are places where the large biomolecules, understanding the chemistry of the life could be done. We could actually examine whether or not DNA is the only game in town or there's some other way to get the business of life done.
So we got to take a quick break before we come back to our third and final segment. This is Cosmic Queries. This is Star Talk. This is Neil deGrasse Tyson. Stay tuned.
Hey, we'd like to give a Patreon shout out to the following Patreon patrons: Matthew Poundset and Tom Bach. Thank you guys for your support. We could not do this show without you. And if any of you out there are wanting your own Patreon shout out, please go to patreon.com/StarTalkRadio and support us.
We're back. Star Talk Cosmic Queries, Search for Life in the Universe. We've got Kevin Hand on hand, who just published a book, and the title is
Alien Oceans.
Alien Oceans. That's just the coolest title of a book ever, and there should be a movie
Thanks.
with that. Right? I'm
Thank
just saying. Okay.
If you get your movie made before my cowboy romantic movie gets made,
Jordan,
that would be so.
I need some strong
mad.
characters in the movie, so we got to combine forces.
Sexy cowboy. I'll send you the script. Okay, we can
Do you
make
mind
this happen.
dying death by squid on Europa?
I'll take anything.
And Kevin, where does squid concept come from? Because in the movie Europa
Report.
the Europa Report, yeah, I think they find a squid there. It's like, what's up with that?
That's right. Yeah, so I consulted on that movie.
You.
I know a little bit about how that came about.
That's how you get. And did you also consult on the movie Arrival? We got more squids.
No, but I
No?
love that movie. It was fantastically well done, and I love the concept of that kind of communication.
I worried. There's the squid thing, the septipod,
Yeah.
drawing these circular patterns on this glass, and no one at any time asked, "Are we seeing these backwards?"
Right. They got it wrong the whole time.
No, just think about that, right? Is the squid drawing for our benefit or for their own benefit?
Right.
I mean,
Yep. It'd be fun to redo that movie from their perspective.
I think the squid was of such high intelligence, they knew, humans are always going to think it's for their benefit. So we might. That's what higher intelligence is. It's knowing that somebody else doesn't care enough about you to understand your own
That's
perspective.
exactly right. Or that their ego prevents them from having any clue about any other way to see the world.
Yep.
Yeah. Jordan, we time for just one or two more questions here.
Great. This is from Facebook and Brent Whitlock. While searching for life on different planets, do we risk contaminating aquatic environments with Earth biology by taking the plunge?
Yeah, Kevin, you're talking about putting landers on Europa and looking for life. Did somebody sneeze on that lander before it left JPL? What assurances do you have for us that you're not going to discover life that you brought there?
Yeah, it's a great question and one that is very important and that JPL and NASA take incredibly seriously. And the short version is that spacecraft that are going to Mars to look for signs of life or going to Europa, Enceladus, Titan, etc., they are baked out and cooked to kill off any microbes, getting rid of any contaminants. They are cleaned extensively and essentially sterilized. And even on top of that, in the Europa lander mission concept, so the lander gets delivered to Jupiter in a biobarrier, sort of a little envelope that makes sure it's perfectly clean. And then the lander goes down to the surface, and even after the end of the mission, we still wanted to make doubly sure that it was not going to contaminate the ocean. And so we have a little Mission Impossible button on the lander, where there's a little thermite system that our colleagues at Sandia National Laboratories have designed, where the last command that the lander would implement is a self-destruct button, and the thermite would sterilize the spacecraft even further by raising it to a temperature with a thermite flames.
Dun, dun, dun,
Exactly.
dun, dun, dun.
You got it.
Tom Cruise's next destination in the next movie.
Yeah, get ready. He's suiting up and training.
We'll get him there to search for signs of life. That'd be great.
All right, Jordan, see if we squeeze in a couple more. Go.
All right, got one right here from Phil Reeves and Facebook. What can finding life on other planets or moons in our solar system teach us about how life developed here on Earth?
Yeah, it's a great one. And it comes back to the origin of life itself. And so right now, there's quite a bit of debate about how life on Earth arose.
Jordan, that's science speak for quite a bit of ignorance. Okay, just so you know. Okay, yeah, okay.
Great. Yes.
Translation.
I'm consistently assuming ignorance, so that's.
But to be clear, it's well-informed, fact-based ignorance, ignorance that's embraced.
Oh, I made a career on that. Let me tell you.
So
how informed is your ignorance?
Smartest ignorance there is. I know everything I don't know.
And so if we think about the history of our understanding of the origin of life on Earth, one of the great experiments was the Miller-Urey experiment, where a spark discharge with some methane and ammonia and water created amino acids, and
all by itself with no help.
That's right. And so ever since then, there have been a number of experiments, and they're kind of, broadly speaking, two camps. One is that the origin of life on Earth occurred in some warm tide pool on the shores of an ancient ocean, bathed in the ultraviolet light of the sun, and then desiccated as that little tide pool dried out. And through various cycling, you then get to life itself. And there's another camp that argues for a hydrothermal vent origin of life. And it turns out that a lot of the chemistry of hydrothermal vents might be conducive to some of the proto-metabolisms that we think would drive earliest life on Earth. And so those two camps, and there are others, but those are kind of two main camps.
Wait, the biggest camp is God did it. That's the biggest camp out there. That's like Camp God. You're so outnumbered by Camp God.
It's the easiest to understand.
Right.
Yes. So coming back,
no complicated words. No.
Right. But let me put it in terms of fact-based ignorance.
Okay.
So at least from that standpoint, there are those two camps of tide pools and hydrothermal vents, and so if we go to Europa or Enceladus or Titan or any of these worlds and do not find life, then that helps inform our understanding of of the modality for the origin of life on Earth. On Europa or Enceladus, there are no continents. There's no sun bathing an ancient seashore. There's
no tide pools.
No tide pools. There's only hydrothermal vents. And so if we don't find life on those worlds, then perhaps hydrothermal vents are not a good place for the origin of life. And we can perhaps conclude that life on Earth arose in tide pools. Conversely, if we do find life there, then that makes the hydrothermal vent origin for life on Earth viable. It doesn't exclude the tide pool theory for life on Earth. I happen to think that the origin of life might be relatively easy and could occur many ways in many different places at many different times. But we have the chance to do this experiment, and the exploration of these alien oceans will help inform our understanding of this issue tremendously.
Well, I think we just ate up all the time we have. We just have time enough just for one deep sentence of reflection from each of you. So, Jordan, what is your deep, reflective, philosophical perspective?
You know, in the times that we live in currently, the times of uncertainty, time in and of itself has felt elongated and slowed down. But hearing about what it would take to get to Europa and that we would have to build cathedrals, not only in our own lifetime, but another lifetime, I feel like this conversation warped time for me and therefore made my existence right now and my complaints about having to be inside for a week or two feel small in comparison. So thank you for a little bit of hope and also for warping the space-time continuum.
So Kevin, he was feeling a little bit of the cosmic perspective there.
There we go. We definitely have to consider the long arrow of time when we engage in these things.
So other than by your book, what one sentence wisdom can you share with us?
I would simply say that we know of the four major sciences: physics, chemistry, geology, and biology. Of those four major sciences, the past several hundred years have led us to an understanding that physics works beyond Earth, that chemistry works beyond Earth, that the principles of geology work beyond Earth. But when it comes to that fourth fundamental science, biology, we have yet to make that leap. We don't yet know whether or not biology works beyond Earth. We don't yet know whether the phenomenon that is us, the phenomenon of life, works beyond Earth. And part of what excites me about the time in which we live, even though it's going to take a while, is that for the first time in the history of humanity, we can answer this profound, age-old question of whether or not we are alone. We can get out there in our solar system and explore these alien oceans that are in our own backyard and figure out whether or not life exists beyond Earth.
Well, what I wonder is the expression curiosity killed the cat. In the case of scientists, there's life on Earth that wants to kill us, coronavirus included, and you want to find life elsewhere. So the confidence that you have that that'd be a good thing, I don't know that that's shared by everyone on Earth when enough of life on Earth would just as soon have us dead. so I'm just putting that out there.
Send the robots and leave the robots on.
Yeah, let the robot I'll sit back and eat popcorn while the robot is looking for life.
Exactly.
Kevin, great to have you on Star Talk Cosmic Queries. Jordan, I love you, man. We got to do this more often.
Neil, I'm here.
Okay, excellent.
Thank you both so much.
Excellent. This has been Cosmic Queries, Star Talk. I'm Neil deGrasse Tyson, as always, bidding you to keep looking up.